Making connections a real-world connection. This is how physics is applied in real-life situations. To simply say it, calculations in physics are not just about theories. It also can be connected and applied in real life. Just like for an example, this intercontinental ballistic missile, which has a larger average acceleration than a space shuttle. Moving forward, we have here the solving for final position when velocity is not constant, where constant acceleration is equivalent to final position is equal to initial position plus initial velocity plus half of acceleration times the square of time where a is constant. This formula came from the combination of different equations. We can start with v is equivalent to initial position plus the acceleration of time. Adding the initial velocity to each side of this equation and dividing it by 2 gives us the initial velocity plus the 1/2 of acceleration of time. Since the initial velocity plus the final velocity over 2 is equivalent to average velocity for constant acceleration, then the average velocity is equivalent to initial velocity plus 1/2 of the acceleration of time. Into the equation for displacement where the final position is equivalent to initial position plus the initial velocity of time, resulting to an equation which is the final position is equivalent to initial position plus initial velocity plus 1/2 of acceleration of time squared, where a is constant. For example, a dragster can achieve average accelerations of 26 meters per second squared. Suppose such a dragster accelerates from rest at this rate for 5.56 seconds. So the question is, how far does it travel in this time? We can solve this by using the following steps. So for the first step, we have to identify the given, where initial velocity is equivalent to 0 and acceleration is equivalent to 26.0 meters per second squared, while the time it takes is 5.56 seconds as it is stated in the problem. For the second step, we have to plug in the given to the equation to solve for the Since both the initial position and velocity is equivalent to 0, we can consider the equation to be the final position is equivalent to 1/2 of acceleration of time squared. Upon following the two steps for solving the problem, we can therefore conclude that the dragster reached a 402-meter distance in just 5.56 seconds. With that, we therefore conclude the following. That's all. Thank you.